These series of videos are demonstrating how to automate economic policy through code. A link to the GitHub repository is included in the video description. In the previous video, we learned how to automate transactions with the rule service and how to develop it. In this video, we're diving into the request create service. And just like the previous one, test a request, explain how the code produces the response, and share the commands to develop it. Alright, open a terminal and make compose up. Open the in-editor HTTP client and the GraphQL collection under the Collections tab. Select the Create Request entry. Now hit the Send button. Pull out the request and response into their own tabs, and we'll open the request create code to explain the response. The code is located under Services, Request Create, Command, and main.go. Now back to the request that was sent to the service. And the story is, Jacob Webb, the debitor or customer, brought milk, bread, and eggs to the grocery store counter, or creditor. And while scanning the items, the person at the grocery store counter created this request. But these tax transaction items, and there are 3 of them, were not initially included. The person at the counter first sent this milk, bread, and eggs transaction item list to the rule service. The rule service found a state tax transaction item rule and added these 3 tax transaction items. If this is new to you, help yourself to the previous video, then come back. Okay. The grocery store clerk now has the rule-tested response, which is milk, bread, and eggs with their taxes, and that is what the request create service will expect, because it too will just send milk, bread, and eggs to the rule service to prove buyers and sellers are servicing their commitments, or in this case, taxes. The grocery store clerk then sends the rule-tested request to the request create service, and the request create service responded with this single transaction request saying, this transaction request was saved in the database with a record ID of 3, a total price of $21.80, and this list of rule-tested transaction items. Now let's switch to the code. In main.go, scroll down to the main function. A web server router is created, and the router is configured with 2 routes. The first route is used by Lambda to test if the web server is available before forwarding the request. The second route calls this handleEvent function with the transaction items decoded into a value of this intra-transaction type. You can find a Go type for this intra-transaction from project root, package, types, and request response Go. Intra-transaction just embeds an auth account, and a transaction which is in the neighboring transaction Go file. So the transaction items list in the request are decoded into this transaction struct, which has a transaction items field. handleEvent returns the response, and the web server sends the response back to the user through GraphQL. The router is then attached to the web server, and the web server is started. Okay, that's the web server. We've got a response to build. Let's move on to the handleEvent function. Scrolling up to its definition, after handleEvent is passed the list of transaction items, identified as E, which is short for event, it's sent to the test values function. On to test values. Now this code was already covered in video 8, but some of it will be repeated here to explain how the response was produced, which was not featured in the services video. Plus, there are changes worth noting. After test values receives the transaction items, some field values are tested, and then test values discovers if the authenticated requester is a debitor or creditor. So author role is an enum of either debitor or creditor. And then that field is set with the authenticated role, meaning in the response, on line 9. The transaction items from the client is then saved in a variable, which are the ones sent by the user. Then another variable of transaction items is created with only the user-added items. The test values function then sends the user-added items to the rule service, and the rule service responds with the user and rule-added items. Both versions of the request, meaning the version sent by the client and the version received from the rule service, are passed to this test prep function, which just returns a watered-down version of the transaction items for convenient comparison and logging. No pointers here. Okay, the length of each transaction item list is compared. The test values function continues if the number of transaction items in both lists are equal. And then test item equality proves all the items in the client were in the version returned by the rule service. From the client, the user sent milk, bread, and eggs to the rule service and received 3 additional tax transaction items to include in the sale. The request create service also sent the client's milk, bread, and eggs to the rule service and received the same 3 additional tax transaction items in the response. From here, client transaction items are proven equal to the rule response. Some values are assigned to the response from the rule service because that's the version used going forward. It may have rule-added approval times. Then test values returns the rule-tested transaction items along with the role enum. Okay, back to where it was called in the handler. The request create service is now convinced the users are transacting their current and expected items. So it connects to Postgres, initializes a service to create a transaction request, and in video 8, a transaction, the transaction items, and approvals were all inserted separately, which would break production, but it's easy to read. Now inserts across these 3 tables happen inside a Postgres transaction using this create request function. The transaction request is created, so this object is available now. And in this tax transaction item, you can see a creditor approval time from the state of California, but that was added by the rule service. Scrolling down to the eggs transaction item where grocery store is the creditor, the creditor approval time property is empty until the transaction request is passed to the approve function. In this case, when the approve function is called, a creditor approval time is added to the transaction request for the authenticated user, which is grocery store. And if the state of California account didn't have a rule, that account owner would have to call the request approve service to add their creditor approval time. Alright, we don't need to dive down into the approve function. That was done in video 8. But you can see the approve all role account Postgres function it calls from project root, migrations, schema, and the approval up migration. Approve all role account just means if you're grocery store, the creditor, your approval will apply to all transaction items where you're a creditor. To wrap it up, creditor approvals from the state of California were added by the rule service. Creditor approvals from the grocery store were added by the request create service. System accounting has now recorded the asking price from all sellers. Now it's just waiting on an approval time from the debitor, which is the next video. To develop the request create service, add code, make rebuild request create to rebuild the service in Compose. Now look at the logs. Alright, clean up with make Compose down. In the next video, we'll move on to the request approve service. You may subscribe, share, and contribute from the buttons and links in the description.